You all know functions well. Let's see some tricky parts of the Python functions. Python functions are written with a new statement def. Unlike functions in compiled languages such as C, def is an executable statement. Your function does not exist until Python reaches and runs the def. In fact, it's legal to nest def statements inside if statements, while loops, and even other defs. When Python reaches and runs a def statement, it generates a new function object and assigns it to the function's name. As with all assignments, the function name becomes a reference to the function object. There's nothing magic about the name of a function. The function object can be assigned to other names stored in a list and so on. Function objects may also have arbitrary user-defined attributes attached to them to record data. Creating a function in Python is very easy. You have to use def statement. So I'm writing def name of a function colon, and inside that you can write a body. So print hello. So this becomes my function. I can call f of, so it prints hello. In Python, function name is an object reference. So here I am creating a function with two arguments, print a plus b. Now I can save this anywhere. So I'm putting this inside a list. So I'm creating a list. My first is function reference. Other two are just integers. So I can call this function by writing L of 0. That's my first element. And for that I am passing arguments. And it prints 5. In Python, I can pass variable length argument for a function by just writing star and name. I'm just printing whatever you're saying. Let's call this function. So f of 1, f of 2, 3, 4, f of, I'm passing characters here. So it can take any argument here. So let's see nested function in Python. So I'm writing first function. In that I'm taking one variable x equal to 10. Let's take another function. So again define x equal to 11. I'm trying to print here x. I'm calling g, print x again, and I'm calling f from here. So let's see the output. So I get 11 for this one and 10 for this one because this is my local variable. Now I'm making it non-local. So there is one keyword, non-local x. Now what happened is x is 10 here, but here we are defined as non-local. So what happens is inner function has changed the value of outer function x, and when you print it here we got 11. Let's play a little bit with the functions. So I'm defining a function f. Inside it I'm taking a variable x equal to 10. So let's define another function inside it. So f1, another function f2, and here I'm trying to print value of x. So my f2 was over. Now I'm out of f2. Inside f1 here I'm returning reference of F2. So I'm out of F1 now. I'm inside F. So return F1. So I'm out. So let's play this. I'm giving A equal to f of, I'm trying to call outside function f, and I'm trying to print value of A. So it gives me output as f1 at some address. Okay, so let's go one level deep. B equal to A. Now here I'm calling f1, not f, and try to print B. So I get this f2 at this particular address. So I am inside f2 now. So let's call f2. So I'm getting here value as 10, which is printed over here. I can do it simple way like this. A equal to f. I'm calling it again. I'm calling it again. Let's see what we get. The value is 10. Let's write a simple function. So I'm writing def, define a function. It's very simple. A equal to 0, and I am taking a while loop. While A less than 10, it's easy to understand. I'm doing nothing here. A equal to A plus 1 and return. So what will be output for this? I'm returning A here. Now when this function will start, we will initialize A to 0. Then it will enter the while loop because A is less than 10. It will make A equal to A plus 1, and then it gets return statement. So while loop will break and it will return. So let's see what output we get. So I'm printing the value, print f, I get 1. So this is very clear, simple statement, easy to understand. Now I'm making some changes in this. So I'm taking the same function and let's execute this. Only one change I'm making here. Instead of return, I'm writing yield. Let's see the output first. So output is generator object f and the address. Now writing yield makes this function as generator function. What does this mean? In the first function, if you see here above, it's a normal function. When you call a function here, the entire function will get executed and the return value will come here. This is in the first case. In the second case, because I have written yield, this function has become generator function. What does this mean? When you call this function will not get executed at a time. Instead, it will create a series of values. Now let's see what these values are. We'll understand what it is. So I'm trying to print values I in f. Print I. So this is what it gives me, a series of all the values. Now what is happening here is f is called again and again, but for every call, generator function creates a new value. How? When this f is called first time, a equal to a plus 1, so I get 1 here, and then it will be returned back to the calling function. This generator function will remember its state. So a equal to a plus 1 is remembered. Then next time when it is called, my a was 1, so he will increment that by 1, it becomes 2. and it will return. Third time it is called, he will increment by 1 and return. So this is a generator function. So there is a very simple difference. If it is written as return, then entire function gets executed at a time and returns the value. In case of generator function is executed step by step. So first step, remember the value, give the result back. When it is called again, he will start from where it was left and give the result back. So this is a special function called as generator function.